Well, hello, everybody. Samuel Singer here from Wyoming Stargazing. Sorry to be a few minutes late, but as you can see, the eclipse has already started in Central Time. We've got Josh Cook, J.R. Dalby, Clint, and I think a couple other folks who are in Mount Carmel, Indiana, streaming the eclipse for you. They drove from Jackson, Wyoming, and made it there last night. As you can see, the eclipse is already about eighth of the way going. I am in Colebrook, New Hampshire, and the eclipse hasn't started here yet. So we will show you footage from both places. So you're going to get to see totality twice here from Wyoming Stargazing. Once at around 3 p.m. Mountain Time. 3 p.m. East Coast time, so about an hour in Indiana. And then you'll see it again about half an hour later here in New Hampshire. So I'll bring up my feed after we get to see totality from Indiana. And if you look really closely at the image of the solar disk there, you'll see a couple spots. There's one really nice spot, almost dead center in the sun. Thank you, sun, for putting that sunspot right where we all can find it quite easily. Sunspots are cool patches in the upper atmosphere of the sun, the photosphere, the part of the atmosphere that we can see using our eyes, and eclipse glasses. Never look at the sun without your eclipse glasses. And so that sunspot is a cool patch caused by magnetic field activity. And those are usually also associated with coronal mass ejections, the eruptions of solar material out into space, which, if directed towards us, give us northern lights. And so that coronal mass ejection is, in fact, pointed right at us. And so that may have been associated with the northern lights that we had, about a week ago or so. We had a lot of cloud cover in Wyoming, so didn't get to see much. But if you looked at the sky live, they had a pretty good prediction of northern lights last week caused by the coronal mass ejection from that sunspot. And to give you an idea of scale, that little spot right there is probably 5 times the size of the Earth. So that tiny little black spot in the center there is the size of the Earth, and you could fit about 20 of those across the diameter of the sun, which means you could fit about 100 Earths across the diameter of the sun. So it kind of gives you an idea of the scale of the sun versus the Earth. And then obviously there's some interesting scale equations going on with the moon as well, as it makes its way across the solar disk from our perspective. So as you probably know, the sun is a whole lot bigger than the moon. In fact, 400 times larger than the moon. But it's also 400 times farther away, which is pretty convenient for us because that means the moon and the sun appear almost the same size in our sky, which is what makes total eclipses possible. You need some object that has an apparent size at least as big as your star in order to block it out. And so there are other planets with moons whose moons are not large enough to block out their sun. And there are other planets that have moons that are much, much larger, relatively speaking, than our moon. And so they get solar eclipses much more often than we do. But our moon, being 400 times closer and 400 times smaller than the sun, is just big enough to block out the sun for us on occasion once every year. Somewhere on the globe. Doesn't always happen in North America, obviously. Otherwise, we probably wouldn't be even talking about this right now. But somewhere on Earth, on average, every 12 months, you get an eclipse. And a little bit later, I'll bring up an image that shows you all the eclipse paths that we've had over the last 100 years or so. And you'll be able to see that, in fact, there's been an eclipse almost everywhere on Earth over the last 100 years. So this one is special because it's the second one in a decade that we've had in North America. The first one, of course, 2017, when we had totality right through Jackson. Thank you, sun. Thank you, moon, for making that happen for all of us there in Jackson. This one we had to travel for. We were all planning on going to Texas because if you looked at the last 40 years of weather forecasts, April 8th looked really, really nice to be a place where it was going to be clear skies for the eclipse. But lo and behold, all the forecasts were wrong. All of Texas and most of Mexico are under cloud cover right now. So we changed our plans about 3 days ago. And instead of going to Texas, we had one group keep driving due east, and they made it to Indiana. I was already out on the East Coast, planning on flying back to Texas. I changed my flight and decided to stay out on the East Coast. And we were watching the weather like hawks over the last couple days from Saranac Lake. And we decided to drive about 4 hours east to the border of Vermont and New Hampshire. Because it looked like this is like a bomb-proof location to watch the eclipse. There's going to be some cloud cover moving in to a lot of New York and Vermont today, but out here on the border of Vermont and New Hampshire, on the eastern border, it looks just awesome. So we shouldn't have any problems showing you totality. Yeah, you can clearly see that image from Mount Carmel, Indiana. If you're just joining us, they are going to have totality about half an hour before I have it here in Vermont. So you're going to get to watch totality twice today, which is pretty awesome. And thanks to those folks in Indiana who are realigning the telescope. It's perfectly aligned now, guys. Thank you so much. Really appreciate that. And it looks like they've got really good weather. There might be some passing clouds in Indiana, but it is totally bluebird above where I am in the border of Vermont and New Hampshire right now. So we should have a pretty good show for you today. And thanks to all of you who are logging in from across the country. See some comments from Jackson, from Kelly, Wyoming, somebody up, Mom, Mom up in Canada. Hi, Mom. Thanks for joining us. And if the rest of you want to let us know where you're calling in from, we'd love to see where you are all watching this stream from. I assume the 56 of you who are logged in right now are from all over the place. So yeah, comment. Another person from Jackson. Hi, Eric. Thanks for saying hello. And yeah, let us know where you are. It's Mary. Hi, Mary. Glad to have you with us. And it looks like we got about maybe a 25% eclipse right now in Indiana, which is super cool. Oh, Katie, good to see you, Katie. She says it is pretty cloudy in Texas. I am so sorry to hear that, Katie, but it's nice to hear from you. Ian Cranston, fire station number 6. Aaron Hardy from Minnesota. Robin Moore from Jackson. And we've got, Don from Manitoba. Hey, Don. Good to see you there. Well, thank you all for joining us. It is going to be pretty exciting here as we get closer to totality. I am out in a field with probably, 300 or 400 other people. There are lots of telescopes that have been set up to show people the sun. I've got a telescope tracking behind me, but no point in showing you the image from that telescope because it looks exactly like the one that we've got up on the screen right now. But we'll get to that one after we get totality from this first location, so you can watch it twice with us. Another Jackson Hole traveler. Nice. Latham Jenkins, thanks for joining us, Jackson Hole traveler. And maybe you guys in Indiana can get the sun. Oh, you're doing it already. You guys are on it. Thanks so much for getting the sun realigned for us. Go Indiana. Yeah, thank you so much for JR and Josh, who drove I think about 24 hours over the last few days to get out there, toting along all of Wyoming Stargazing's streaming equipment. And thank you, Elon Musk, for letting us use your Starlink receiver. They're using Starlink in Indiana for that live feed, and I am doing a hotspot on my phone here in New Hampshire. Annie, you are very welcome. We are excited to be doing this stream for you. Oh, there's JR and Clint. Hey, guys.
And it's powered by a Prius.
And you're powering it all by a Prius. That is cool.
Powered by a Prius.
Yeah, that's very cool. Nice. Excellent. Yeah, shout out to Annie at Coulter Elementary School. I hope you and your students are watching. We were hoping to be able to do this stream right at lunchtime for totality. Had we been streaming from Texas, totality would have been at like 12:30 p.m. Mountain Time. So really good for kids at lunchtime. But unfortunately, Texas is not just going to happen today. So totality is going to be a little bit later on for our viewers. So hopefully there's still some classrooms who can at least stream totality for a few minutes. And again, if you're just joining, we'll have one viewing of totality at just around 3 p.m. Eastern time, 1 p.m. Mountain time, and then a second viewing of totality just about 20 some minutes after that at around 1:25 Mountain time. So you'll get a chance to see it twice if you really want to, which I think is pretty cool. I only saw totality once back in 2017. So I'm psyched to be able to see it once virtually and then once in person here. Oh, my Auntie Natalie is here. Her kindergartners are watching from Golden Hills High School in El Dorado Hills, California. Thanks for tuning in, Auntie Natty. All right. Well, I think I'm going to bring up some other images of eclipse history, because I think it's actually pretty interesting. We've known about eclipses and how to track them for a really long time, but I don't want to take away this image of the partial eclipse that you're seeing. So let me see if I can bring up a second image here without taking that away. If it turns out that that image goes away, I'll have those guys reshare, because I definitely don't want to have you guys lose that image as well. Let's see if I can recenter that image here. And yeah, it looks like we will lose that image of the partial eclipse if I start sharing my screen, but it's okay. We've got a lot of time until totality. So let me show you a couple cool images and a little bit of history of eclipses and a little bit of the science back behind them, and we'll go back to this image of the partial eclipse in about 20 minutes, 30 minutes, and there'll still be plenty of partial eclipse to see after that. And so just bear with me for a moment here while I bring up these other images I want to show you, and then we will learn a little bit more about eclipses. All right, I've got those images pulled up. For those of you just joining us, we're gonna switch from the images of the partial eclipse that we're streaming to a little bit of history and science about eclipses, and then we'll come back to the image of the eclipse with plenty of time to see totality. So I'm going to start sharing my screen here. Just pulling up the slideshow. And we're getting there. StreamYard is asking me for all kinds of permissions to access all my Google files. StreamYard is the service we're using to stream live simultaneously on multiple different platforms on Twitch, YouTube, and Facebook. And here is my slideshow to show you guys some stuff about the eclipse. It's coming up. Hey, my brother just joined us. Hey, Howie. Thanks for joining us from outside of Winnipeg, Manitoba. Looks like it's cloudy in Manitoba where he is as well. All right, I'm going to bring up some eclipse images for you here, and we'll come back to the live stream in just a minute or two or three. So if you folks remember, the 2017 eclipse was known as the Great American Eclipse. So this is the second Great American Eclipse, this time of 2024. So as I was briefly mentioning earlier, we've known about eclipses for a really long time. And how to predict them for a really long time. In the upper left-hand corner, that is an image from a piece of a rock from a cave in Ireland. And it is the oldest known record of an eclipse. That one is from about 3300 BC. And what you're seeing there are depictions of the sun, stars, and the moon eclipsing the sun. We've been able to pinpoint the date that eclipse occurred on. It was November 30th, 3340 BC. And so the ancient Celtic people of Ireland were the first to actually make a record that we know of. We also know that the Babylonians... It's a piece of... Oh, great. I just found out from my nephew Logan that we just started the partial eclipse here in Vermont. So we are on our way. Very cool. The Babylonians also kept really early records of eclipses, not quite as old as the one we know of from Ireland, but the Babylonians figured out something else that was really, really cool. It's called the Saros cycle. And it's a cycle of over 5,000 days in which the moon, sun, earth system change positions. And the cycle repeats every like 5,800 and something days. And somehow the Babylonians figured this out. And it's still the cycle that we use today to predict eclipses, the Saros cycle. And we know the Babylonians had that figured out about 2,000 years ago. Looks like someone is in Salt Lake, kind of cloudy there as well. Sorry to hear that. And so Babylonians figured that out about 2,000 years ago. We have ancient records of eclipses from the Middle East, from ancient Greece and Rome about 2,000 years ago. And there's some really cool folklore regarding eclipses from Japan and Korea. And so up on the upper right-hand picture, there's a picture of that dog eating the sun. It's a Korean legend about what happens during an eclipse. For the Japanese, it was a dragon eating the sun. And so the words that we use for eclipse in Japanese I don't know how to correctly pronounce it, but she, I believe, is something close to that. My apologies if I totally butchered that for anyone who speaks Japanese out there. It actually means to eat, to devour, and so that's what was depicted in their legends about a dog stealing the sun or dragons eating the sun during total solar eclipses. Interesting history of eclipses down in our part of the country in Wyoming. This is a picture of the 1878 eclipse. Actually, the photograph is taken from Denver, Colorado. Oh, I just heard from someone in Texas. They're actually seeing the eclipse through the clouds there right now. So at least they're seeing something. It's probably, the sky's probably darkened in Texas right about now. And they're seeing some part of the eclipse through the clouds. That is awesome. I'm glad you guys are getting at least a little bit of a show in Texas. That is fantastic. Somebody just asked if we're going to show Totality live. Oh, definitely. Yeah, Totality will be live through the telescopes, through both of them. I'll also be watching here in Vermont or New Hampshire when it happens. So anyways, getting back to this eclipse in 1878. So a lot of people came to Denver, Colorado to watch it, also to Evanston, Wyoming. Notable scientists, including Thomas Edison and the woman who I have pictured here, which is Maria Mitchell. Maria Mitchell was one of the first professional female astronomers, only the second female astronomer to actually get paid for what she did. Carolyn Herschel was the first, about 100 years before Maria Mitchell. But Maria Mitchell was the first to lead an all-woman expedition for any scientific discipline, and the first all-woman expedition to an eclipse. And so this is a picture of her and her colleagues who are out taking meticulous notes and drawing images of the eclipse during all the partial eclipse and then of totality as well. And there's some beautiful poetic words that she used to describe the eclipse. But I'm not going to read those to you now because they kind of spoil what you get to see during totality. For those of you who haven't seen totality, I don't want that to be a total buzzkill for you. So we'll wait until after totality to share Maria Mitchell's words. Maria Mitchell went on to be a notable astronomer. She has an observatory named after her on Nantucket Island, and I think was one of the first women ever to be inducted into the Academy of Arts and Sciences. So amazing accomplishments for anybody, let alone someone who was facing incredible discrimination as a woman to be a professional scientist of any kind during the late 1800s. But she was really an amazing trailblazer for scientists, but specifically for women scientists. Most of you will probably recognize the guy on the left. That's Albert Einstein. On the right is Sir Arthur Eddington, and they are posing for this picture shortly after the 1919 total solar eclipse that occurred in South Africa. Einstein had recently published his general and special theories of relativity, and there was no observational evidence to support those theories. It was just mathematics at the time. Brilliant mathematics, but still not objective, rigorous science. It was still theoretical. But one of his predictions was that the gravitational field of the sun should actually distort the light of stars nearby. And during a total solar eclipse, the sky becomes so dark that the stars just off the edge of the limb of the sun become visible. And so Arthur Eddington knew that, and he traveled down to South Africa to photograph the total solar eclipse, and laboriously took images using glass plates and photo emulsion. Right, this is 100 years ago, so no digital photography at the time. And he got these images, went back to his lab, measured the positions of the stars, and lo and behold, they agreed perfectly with Einstein's predictions. And so the headlines the next day read, relativity vindicated, Einstein correct. And then apparently there were reporters who went to Albert Einstein's home, and he said something like, well, of course I was right. So apparently not the most humble guy, but very confident in his mathematical predictions. And of course, that was just the very first piece of evidence that confirmed relativity. And there have been, dozens and dozens of other scientific experiments that have been done over the years, all of which have confirmed Einstein's theory to a larger and larger degree of certainty. And so it's just interesting that the very first piece of evidence came from a total solar eclipse. Let's see. Tell you a little bit more here. Looks like we still got plenty of time before totality in Katie in Texas says they're approaching totality. Very cool. I think they're just moments away in some parts of Texas right now. So just a little science about eclipses. Two different types of eclipses, lunar eclipses and solar eclipses. On the top of this diagram, you see what lunar eclipses are like. That's when the Earth gets right between the sun and the moon. And of course, the Earth's shadow is enormous because we are much, much closer to the moon than we are the sun. And so the Earth's shadow completely covers the moon. And so really from any point on half the Earth, you can see a lunar eclipse. And so lunar eclipses, they're not that provocative compared to solar eclipses because you can be anywhere on half the Earth and see a lunar eclipse. Not so with solar eclipses that you can see depicted down below. When you have the moon in between the sun and the Earth, the shadow of the Earth, the inner part, the umbra, that actually hits the Earth is so small, at most just over 200 miles wide. And so you have to be in a really particular point on the planet to actually see a total solar eclipse, which is why people have to travel to go see total solar eclipses. And so that's why I'm out here in the eclipse path in New Hampshire, whereas a lot of folks across the country are just getting a partial eclipse. Folks who are in the umbra, folks who are in the penumbra just get a partial eclipse. But those of us in the umbra get the full shebang. And you might know that eclipse chasers are also known as umbrophiles, lovers of the umbra. And so you can actually think of us as umbros. I know that's a little... very male, umbros, but that's what we're called, umbrophiles or umbros for short. Anyways, on average, there's a total solar eclipse somewhere on Earth every 12 months, but the locations change year to year. We've been lucky in North America to have 2 in the last 7 years. It's going to be another 20 years before we have a total solar eclipse in North America. But I mentioned earlier that I was going to show you an image of all of the eclipse paths in the last 100 years. We're going to get to that image in just a couple minutes here. But before we get there, I want to tell you about my favorite word in astronomy. I try not to use much jargon when talking about astronomy, but this is my favorite word, so I am going to teach you this word, syzygy. Syzygy is when you have 3 celestial bodies perfectly lined up along the same orbital plane. And so for us right now, it's the sun, the Earth, and the moon in this perfect alignment, this syzygial alignment that gives us a total solar eclipse. So I learned this word back in 2017 when I was researching eclipses, and it's definitely still my favorite astronomy word, syzygy, the alignment of 3 celestial bodies in space. just here another example of the alignment that we have right now, the sun and the earth and the moon. Some of you may already know that you have to have a new moon for a total solar eclipse. That's the only time there can be a total solar eclipse, when the moon is right between the sun and the earth, so that the illuminated side of the moon is facing the sun and the unilluminated side of the earth is facing unilluminated side of the moon is facing earth. So that's what we've got today. And the reason we only have an eclipse every year as opposed to every month, right? We've got a new moon every month. Why don't we get a new moon? Why don't we get a total solar eclipse every month? It's because the moon's orbital plane is slightly offset with respect to the Earth and Sun orbital plane, just by 5 degrees, or a little under 6 degrees, actually. But it's that tiny displacement from the Earth and Sun orbital plane that makes eclipses just rare enough for them to be really exciting events. If we had a total solar eclipse every month, right, every time the moon came between the sun and the earth, we wouldn't be having this conversation right now, and no one would be an eclipse chaser. We would just watch the total solar eclipses that happen from our homes every month. But this 6 degree, 5 degree offset of the moon from the orbital plane of the earth and the sun is what gives us the once a year frequency of eclipses. And so that's really why there are these magical events that we've had throughout history. And it's not just the science that we get to do during total solar eclipses. We get to see the outer atmosphere of the sun naked eye during eclipses, and scientists can get all kinds of really wonderful data during eclipses using sophisticated instruments. But just the the sight of a total solar eclipse, for those of you who have already seen one, you know it is undescribable. There is something so special about standing underneath a total solar eclipse. So I hope that all of you get to do that someday if you haven't already. So here's that chart that I was mentioning earlier, all the paths of total solar eclipses over the past 1,000 years or so, from about 1,000 to 2,000. So you can see over the course of 1,000 years, we've had eclipses almost everywhere across the face of the earth. But 200 some miles at a time, as they arc across land, or more frequently oceans, because there's just a lot more surface area that's covered in ocean. This is the path that we have today across the U.S. The eclipse first made landfall in Mazatlan, Mexico, and headed up through Texas, a little bit of Oklahoma, up through the Midwest, and then into the East Coast, New York, Vermont, New Hampshire, and Maine. And so this time around, the moon is a little bit closer to the Earth, so it's a little bit larger in apparent size, which means its shadow is a little bigger. So the path is a little wider, and totality is a little bit longer. So for those of you who will remember the 2017 eclipse, I think we had maybe 2 minutes and 18 seconds, something like that, of totality. In some places of the country, there's over 4 minutes of totality right now for this eclipse. And then out here, we've got about 3 minutes where I am, with clear blue skies. So yeah, the timing that you get and the area that you get to see a total solar eclipse depends on how far away the moon is from the Earth during the time of eclipse. The moon changes its distance with respect to the Earth all the time, because it's not a perfectly circular orbit. It's a parabolic orbit, just like all the planets have parabolic orbits around the sun. Or excuse me, elliptical is the correct term. I don't know why I'm using parabola. Elliptical orbits, very close to perfectly circular, not nearly as much curvature as a parabola has. Elliptical orbits. And so that elliptical orbit is what changes the duration of eclipses. from one year to the next. Just some more technical details if you're interested about eclipses. They can last as much as 7 minutes. So we're kind of like right in the center of that with about 4 minutes in some places, 4.5 in some places, but 7 minutes total. About 115 miles wide with this one, can be up to just about 200 miles wide. And 15 states are getting covered this time, which is pretty cool. So let's see. I had an image. I think there was one image I wanted to show you here. I'm not going to go here. Here you go. So this was an image taken in 2017. So this is a multi-exposure composite image taken during totality by one of the Wyoming Stargazing board members. And so we're not going to see this much detail through the cameras we're using to live stream, but it is going to be somewhat similar to this. We'll be able to see the corona naked eye. You don't get to see the face of the moon like that naked eye. It's just backlit too much. But if you do different lengths of exposures, you can bring it out during totalities. This was an award-winning picture taken by Mike Adler, one of the Wyoming Stargazing board members back in 2017. And I think Mike is going to be here with us here in New Hampshire pretty soon. I think he's driving up right now. So I'm excited to experience this second eclipse with him. And so I'm going to stop this presentation right now and go back to the image of the partial eclipse in Texas, or excuse me, in Indiana. And if anybody has any questions about any of the stuff that I just talked about or anything else about eclipses, just type your question into the chat in Twitch or in YouTube, and I will be able to see it here. And I'm happy to answer any questions that you have about eclipses as we enjoy watching the last part of the partial eclipse in Indiana. It looks like they're about 3/4 of the way through there. That big sunspot right in the middle of the sun is now covered up by the moon, which is exciting. Definitely they have made some progress there. And so they are just about, I think, 18 minutes away from totality. So in 18 minutes, we are going to get to see totality from Indiana. And then about 25 minutes after that, we'll be able to get totality from here in New Hampshire. And all the cool stuff really happens in like the last few minutes before totality. That's when the sky starts to get dark. The temperature will probably drop about 10 degrees. Oh, okay, totality just happened in Texas. They said it was incredible. They got 2 glimpses of the corona through the clouds. So they did get to see a little bit. I'm so glad they got to see something down there. I know the forecast was not looking great in Texas, but thanks for letting us know, Katie. So glad that you got to see something there, albeit for a second or two. Katie, if you want to share anything else about what you experienced, feel free to type it into the chat. I'm sure folks are eager to hear what it was like for you. And yeah, it's definitely getting closer and closer to totality time in Indiana. I think we got a question here. Oh, I'll take a look at it in a minute. Thanks. Yeah, so I'm here with my mother-in-law and my sister-in-law and my brother-in-law and my 2 nephews. We were, my wife, Becca, and daughter, Simone, and I were all out here in Connecticut for Evan's bar mitzvah. Congratulations, Evan. A nice eclipse bar mitzvah for you. And it was a really lovely weekend, and my wife and baby decided to fly back. My daughter's just 1.5, so she probably wouldn't have known what was going on anyways. And so, there's another eclipse in the U.S. in 20 years. She'll be 21, so I'll buy her first beer for the next eclipse if she, already hasn't done any underage drinking. We'll see about that. See if Daddy has anything to say about that. Simone says hello. My wife and Simone are watching the live stream right now. So yeah, it's been great hanging out with these folks. We had a nice driving tour today to get out here, and yeah, couldn't have had a better day of weather for the eclipse out here in Vermont, New Hampshire border, and it looks like things are going to work out really nicely in Indiana as well, and they worked out as best as they could in Texas. They didn't have complete cloud cover. I guess they got to see a little bit, which is wonderful. And so yeah, I'll stop talking for a few minutes here. If anybody has any questions, feel free to put them into the chat, and I can answer any of your questions about eclipses, and really anything is fair game about astronomy as well. I do know a little bit about other things in astronomy, so happy to chat about that stuff with you as well if you have any questions related to something astronomical. Yeah, they said I can't see anything from Florida yet, from Kimberly Walker Laidman. Yeah, I think the partial eclipse, I think you get a tiny bit of partial eclipse in Florida, maybe like 15-20%, something like that from northern Florida. My dad said they just watched 35% coverage, totally clear in Nevada. Makes sense. It's always clear in Nevada, except when it's not. And then there are flash floods and all kinds of stuff. Let's see here. We are getting close in Indiana. Looks like they've got about 85% eclipse right now. And just a reminder for you folks in Indiana, you do need to remove the solar filter off the front of the telescope during totality so we can see the corona. We won't see anything through the solar filter. So if you haven't already started unscrewing the solar filter, you should do that because we won't be able to see anything through the solar filter. You can't take it off until totality begins, but yeah, you're going to want to start unscrewing that solar filter so you can get it off really quickly when totality begins, so we don't miss any of that amazing corona. And speaking of the corona, let me tell you a little bit about that. We didn't really talk about that. So the corona is that ghostly outer part of the atmosphere of the sun. And it turns out that outer atmosphere is actually dramatically hotter than the photosphere. The photosphere is the part of the sun that we see, and farther away out into space is where the corona is. We only get to see during a total solar eclipse. And so when we get to see that, we are looking at that thin outer atmosphere of the sun that is over 1 million degrees Fahrenheit. The inner atmosphere that we see, the photosphere, is only about 7,000 degrees Fahrenheit. So way, way hotter out in the corona. Astronomers don't really understand why or how so much heat gets transferred out to the corona. It's kind of ridiculous how hot it is out in the corona. It's so hot that a lot of the radiation that we get is actually an X-ray radiation, way on one end of the electromagnetic spectrum, about as intense radiation as you can get from a star without it exploding, in which case you can get some gamma rays. But yeah, that corona actually shines in the X-ray range, which is just ridiculous. Yeah, it's pretty amazing that we actually get to see it naked eye during totality. And it extends, as you can see, several sun diameters out into space. And you can even see it move a little bit. It's always changing its orientation and position. And I think we need to turn the car on here because we're running the computer and the telescope off the car battery, and I'm hearing the inverter beep. So I think that means we need to run the engine a little bit so we get a little bit more juice. So if speed breaks, I'll be right back. But I think we're still good here. Now we've got the engine on, and nothing happened. So I think we're still streaming and all as well. Let's see. Looks like they're almost at 90% totality. We've got third period physics watching from Jackson. Thanks for tuning in, guys. Nice to have you with us. We've got Evan Bryson, a stargazing leader from Jackson. He's with his 6th graders in Jackson Hole Middle School. Thanks for joining us, Evan. Anna Sullivan from Jackson. Excellent. And we are definitely getting closer and closer to totality in Indiana. Chris Berner, thanks for joining us. Nate Struble, Dylan. Oh, hey, Evan. Evan, he's in Florida, one of Evan's buddies. All right. So we are beyond 90% eclipse in Indiana right now. They've got the sun really nicely centered for us in their live stream. So we should get a great look at totality there. We are getting down to it. Just a few more minutes for Indiana, and then we'll have another 20 minutes or so here. I'm just going to make sure that my telescope is still positioned because we're going to want to make sure that it's aligned shortly after totality in Indiana. And so I'm just going to stick my head back in the telescope on here, and I'll be right back with you in just a moment. Looks like I need to realign my telescope a little bit. So let me give it a little nudge, and then I'll be right back with you here before totality happens in Indiana.
Did you see those ones too? Except using it, I just want to make sure the battery's not dying. When it's connected, we can
All right, I'm going to take a peek and see where we're at here. Looks like we're at about 35% here in New Hampshire. Those guys are maybe 93, 94%. Hey, you've got third period study hall present as well. Hello, guys. Okay, we are getting close here. You guys ready in Indiana to pull off the filter? Give me a thumbs up, JR. I can see you there. All right, he's ready. Actually, JR and Josh, if you guys want to give some commentary here, this is kind of your moment. Tell us what you guys are experiencing in Indiana here. I think you have to unmute. Hang on. All right, how about now?
Okay, it's cooling off here a little bit. The traffic is slowing down. Josh is getting really shy, doesn't want to talk on screen. Everything else is going really cool. We're having fun. I can't believe after 6 months of anxiety and deciding where to go at the last minute, heading to Indiana instead of San Antonio, it's amazing. It's pulling off. We have clear sky here. It's just incredible.
Nice. And JR, one thing you might want to try in the next couple of minutes, if you just kind of like stick your hand out in front of you and let the shadows hit the ground, you might start to notice some very strange things happening with the with shadows. Have you noticed anything like that?
Yeah, Clint has been playing around with that. And we have one of the coins that you gave away at the 17 eclipse. We've been playing with that as well. So we're doing all kinds of fun stuff here.
Yeah, I can see some small trees in the background. If there are any other trees close by, you'll start noticing that the shadows cast by the trees are all in the little crescent shapes.
Absolutely. Well, I don't mean to be rude here, but we have cameras and we have stuff that we want to do photos. So we're going to turn off here and get ready for the big event here in about 5-6 minutes.
Yeah, do it to it, man. Thanks for adding a little piece there.
No problem. I got to have some. Can you mute me from there, or do I have to mute here?
Oh, I got you.
Okay, thanks.
Yeah, thank you. All right. They are getting close to totality in Indiana. Looks like they are maybe like 4 minutes away. They are getting really, really close. We still have a while to go here in New Hampshire. Another 20, 25, 30 minutes almost maybe. But yeah, those guys are going to get some pictures through one of their telescopes. And oh, we just lost their feed. No! Oh no, I cannot believe that just happened. I hope they get their car battery or whatever it is working. All right, I will bring my feed up. I think I've got, I don't have an image of the partial eclipse for you, but I'll get that shortly. Hopefully those guys will get their their stream restored. I cannot believe that just happened. What suspense. I promise we're not doing this to you on purpose. Something just happened with their stream. Hopefully they will get it back momentarily and we'll be able to show it to you. Oh no, they have totally dropped off. It is unbelievable. Oh man. Hopefully they know they've dropped off. I am going to call them and see if they can get back on. They are totally off the feed right now. Man, that is wild. I cannot believe that just happened. Hopefully I can give them a ring here and we can get those guys back on. I don't even know if they know they're off the feed. But hopefully they will join us again. They've got like a minute to totality. Okay, they say they're trying to get it back on. Oh man, I cannot believe that. Oh, they're calling. Hello? What happened to the laptop? Is it? Okay. Sounds like they didn't have the laptop plugged in. So they just plugged it in and now they are getting it back up in just a minute. Hopefully they will get it back up before totality is over. If not, you'll get to watch it here in New Hampshire in Colebrook in just about half an hour. But hopefully those guys, oh, it looks like they're getting it back up. Okay, they are back up. And where's that lovely picture? Are you guys in totality yet? Okay. Woo! Nice save, gentlemen.
Excellent.
Can you unmute us once?
Oh, man. That would have been one for the books. Not the books you want.
Sorry about that,
But,
Samuel. We had a low
it would-
power problem, but we're back on live. If it goes down again, we're enjoying totality without you. Sorry.
Glad to hear it. Nice work. Oh boy. Boy, that would have been something, all right. I think if you guys move the image just ever so slightly down, it'll be a little more centered for those of us watching the stream. It may look a little bit different from what you guys see, but for us, the image of the sun is kind of right up at the top.
Why is it?
I wonder if it's frozen. Actually, you may need to restart that application. If it's not moving when you're changing the position of the telescope, it means that it's frozen. Sometimes that happens. So yeah, you have to. I figured it'd be a little bit closer to totality already.
Ooh.
Is it back?
Yeah, I think so. So now we'll.
Yeah, it should be much closer.
No.
Yeah, that looks about right.
Yeah.
There we go.
Now just need to zoom out. Yep. There you go. Yeah, and the camera's not going to know what to do right now. It's going to look a little overexposed like that, but get ready to pull off that filter. Here we go for totality in Indiana. They are down to like 2 or 3%. And then we are going to see the outer atmosphere of the sun in just a moment or two. Here we go. If you look really closely at the edge, you may get to see what's called the diamond ring effect. I'm not sure it'll be visible through the filter, but if they pull it off at just the right moment, you'll see this little glimmer of light, the last little bit of light that actually comes through the valleys between mountains on the moon. You may not be able to get to see the effect on the stream, but it does happen whenever you're watching a total solar eclipse. What's called the diamond ring effect. It's just for an instant. We were able to get some great pictures of it at the 2017 total solar eclipse, and we might get to see it on the live stream here. So it looks like you can see that things are starting to get a little bit dark in Indiana. My guess is they are experiencing a temperature drop. If there were any birds singing there, they're probably not singing anymore. And we are just moments away from totality. Here we go. One little sliver left of the sun in Indiana.
Ready?
It is just about gone.
This is it.
Any moment now. You guys remember, you got to take off your eclipse glasses and look at the sun without your eclipse glasses and without the filters on the telescopes as soon as this happens. The only time you can look at the sun without eclipse glasses is during totality. And it is just about to happen in Indiana.
Your lights just turned on your car.
Oh, nice. Yeah, it is starting to get dark there. One little sliver of the sun left. Got a countdown happening online. You guys were a little early, but that's okay. Here it goes. They are just about there. Maybe we'll get to see the diamond ring effect. You guys can you can go ahead and pull off the filters now. It'll be safe to do so. And as soon as that last little bit of, oh, diamond ring effect. Whoa! There you go, folks. That is a major diamond ring effect for you right there. Wowzer. Nicely done, gentlemen. If you look really carefully up at the top, you'll see that the edge is not even. You're actually seeing sunlight pass through all the little valleys and mountains around on the edge of the moon. You can see how dark it got in Indiana right now. And there is the solar corona for you. Guys, hit record if you haven't hit record on the camera. We've got the footage obviously saving on StreamYard, but we can get the raw footage saved on the camera. So if you guys haven't hit record, hit it. Wow. Look at that. You can see some prominences, those little pinkish dots up on the edge. Those are prominences. Those are huge ejections of solar material getting blasted off into space. And you can see that ghostly corona sticking out there. Oh, yeah. That is fantastic. Yeah, so that corona is 1,000,000 degrees. It's actually emitting in X-rays. Wow, look how dark it got in Indiana. That crimson light is what we experienced in Wyoming back in 2017. It was so cool, and man, I cannot wait to experience it here in New Hampshire in about 20 some minutes or so. We're about 50% here in Colebrook. Oh man, that is a sight for sore eyes. Wow, it's it's pretty incredible just to see a zoom of it. There's some big prominences in the upper right and the lower left. Wow, that is cool. Oh, thanks for that adjustment, guys. Very nice. Oh yeah, there's a huge prominence down there at the bottom. That is so cool. Well, this is the first live stream of a total solar eclipse we've done with Wyoming Stargazing, and mission successful. I was a little worried when we saw the forecast in Texas, but we pulled an audible and despite some power issues, got it back online just in time for totality. Wow, that is so cool. I am stoked to see it live here in just a little while. And once we get past totality, I'll bring up the stream from here, and we'll get to do it all over again, which is pretty exciting. But wow, look how dark it got in Indiana. That is so cool. It looks like dusk there. Very, very cool. So cool. Wow, big prominences down at the bottom. Those little blobs you're seeing down there, just big ejections of solar material. Those are probably like 10 times the size of the Earth. Huge fireballs getting shot off into space. That is so cool. Wow.
I got this one.
Oh, is that it? Totality's over, guys?
No, not yet.
I think. Oh,
our alarms are going to filter them.
Okay. Yeah. Wow. Thanks so much, guys. That was pretty cool.
Yes, there's a diamond.
Oh yeah. Nice. Yeah, we just saw the other edge of the eclipse. Back to the partial eclipse come out. Thank you guys. Thank you guys so much for doing that in Indiana. That was so cool. I'm going to get our projection going, and then we'll stream here as well. Hang on.
That was great.
Just hang on.
I put this one on perhaps a little bit early, but you could actually see it come back with the filter on.
That was 3 minutes. Wow.
That was 3 minutes.
Oh, look, you can still see the planet out.
Yeah, you could.
I guess it is.
Oh wow.
Wow. I don't know about you, but I think I got some really good pictures. Did you do the looking at it all? I didn't do it. It took too much work. It was too much. It was too much. I put it on and then I had an error on my camera and I'm like, no, we're done.
Okay, I'm gonna put this back in and get. Oh wow. What do you think, guys? Hey, come on, group hug! Yay!
That was pretty good.
All right.
That was pretty good.
Yay, Team Indiana! Yay! The lights on the Prius was special. That was the best.
It's still on.
Did we lose Sam though?
The stream seemed like it was cutting out for a second.
Okay.
We're still going. It looks. Sam, can you still hear us?
Yeah, I can still hear you. Nice to hear you guys celebrating.
Go
Your dad to get into
We're on
it's
mute
going
right
for
now.
me. Go.
Hey, Samuel, can you hear us?
Yeah, we can.
That was worth every minute. That was unbelievable. Oh man, you guys,
I'm
what do you guys,
glad to hear.
45 minutes out?
Something like that. I'm just about to bring up the image of the sun that we're looking at here.
Okay. I think I got some awesome photos too. We had a bunch of cameras going along with the live feed. So this will be fun. Once we'll produce them tonight.
Wonderful.
On the website.
That's
Thanks
great.
for,
All right, I'm going to. Yeah, thank you, JR. You guys crushed it, man.
Well,
nicely
it wasn't.
done.
It was a lot of work, but thanks for your support, and I'm glad we pulled it off.
Yeah, you guys pulled it off very, very nicely.
And it wouldn't be right if we didn't have an emergency 2 minutes before. It just wouldn't be right.
No. I mean, I'm almost glad that the laptop died right then and there. Well, cool. I'm really glad that you guys got to experience that. We're at about 75% here right now, and it's it just started to get a little bit darker here. Got a little bit of wind that just picked up, and I'm going to take a look at my eclipse glasses here. Yeah, we're at like about 75-80%, as you can see.
Yeah, I can see yours now. Yeah, this is awesome. Well, we're gonna mute here and we're gonna enjoy and have lunch.
All right, you guys do that, and I don't know if you guys saw, but you pulled the filter off at the perfect moment for the diamond ring effect. We got the most amazing diamond ring effect when you guys.
We
pulled
planned it that way.
off.
We designed it that way. Come on.
It was absolutely mesmerizing, way cooler than actually seeing it in person.
I love it. It's recorded, so we can see it later, right?
It was so cool, man. It just got really cold here. I'm gonna put my coat on. It probably just dropped like 10 degrees, and the wind just picked up.
I can hear it.
Yeah. We were getting close.
Okay, well, we're going to sign off. Have fun.
All right. See you guys. Drive
Bye.
safe on the way back.
Thanks. We're going to stay here tonight. We're driving back tomorrow.
All right. Sounds good. We'll
Bye.
see you guys. Bye. All right. We are approaching totality here in Colebrook, New Hampshire. You can see a little sunspot on the part of the sun that's not totally eclipsed right now, and there are lots of people who are starting to get excited out here, including me. I am pretty stoked, and we'll go ahead and take off the other folks who just signed off, and I'll give you a bigger picture here. Keep adjusting it here and make sure you get to see. Field of view is a little bit smaller on this camera, so we won't get quite as much totality or quite as much of the corona as we did with the last shot, but it still should be pretty good. Yeah, it just got a lot colder here. Yeah, just starting to see some strange shadows, which is pretty cool. And let's see if I can make the image a little bit bigger here for you. I think I can. There we go. All right, and I am gonna start recording here before I forget. If I can remember how to do that. All right. All right, folks, I've got our eclipse image recording here now from New Hampshire. It's starting to get really weird out. The shadows are getting a little strange and it's getting cold. We're getting really close. We're about 85%. You can see that one little sunspot about to go into eclipse, which is pretty cool. Hey, I just saw that my second cousin, Sid, just logged in. Sid, good to see you. Thanks for joining us. Bunch of other folks. Thanks, everybody, for being here. We're about to see totality for a second time in New Hampshire. There goes that little sunspot, about to get swallowed up there. Right near the center there is a little sunspot, but it's about gone.
Oh, so hard to see.
Let's see here.
The angle is different on the telescope than when we see.
Oh, it's flipped in a telescope. Yeah, the image that you see in the telescope is flipped a little bit because of the glass. I know there is a way to make this screen bigger. Let's Let's see, full screen layout. Maybe. I don't know why it didn't do that, but that's okay. Whatever. We're streaming here. That's the important thing. We are getting close. Down at about 90%. Oh yeah, I remember this.
When will be the next one in the U.S.? Oh, not the U.S. The next one just nation.
Oh, about a year from now, will be another one. Wow. There it goes. Hope you guys are getting your phones ready to get images and video.
Yeah.
Yeah, you can zoom in and get some great shots.
How? If you need the glasses on.
No, during totality, you guys can use your phones and film directly. Yeah. We are getting close here. Sorry, I don't have that centered perfectly. I'm going to try to get it better for us here. Little more suspense for you there. Little more suspense for you there from New Hampshire. We are getting really close here. Just a few more minutes and then we'll be in totality. The light is starting to get very strange. Shadows are starting to get very strange.
Shadows getting strange.
There you go. There's a bigger view. You should notice there isn't a nice clean line on the shadows of your fingers. You see that? It's kind of fuzzy on both sides.
Oh, that's
Here we go, folks. Just about at totality here in New Hampshire. Just a few minutes away. 95% or so. We are almost there. Everyone just got really quiet here. People were making a lot of noise earlier, but now folks are just kind of like watching in anticipation. Here it comes. We got a few more minutes until totality. The dog that we have here just started whining. Down to about 95%. Yeah, right? Oh, here we go. We are close. Huh? Yeah, I'm going to pull it off there in just a minute. Sure. Yeah, don't worry. Very close to totality. Wow, the wind totally just stopped here. Now it's dead still. That's a great question. Changes in atmospheric temperature. Here we go. All right. We are going to hopefully get the diamond ring effect for you again here.
Oh my God.
Here we go. Getting very close. Couple more moments.
Mom, look at darkness. I feel like I'm gonna go blind. Oh, guys, can you
Almost there.
It's getting kind of windy. Hey. No, again.
Gotta be kidding me.
God. Oh my God. That's good. Hey, Mom, look how dark it is.
Well, we're getting these incredible things called shadow bands here, folks.
Oh.
Oh, Jupiter just came out. And here you go. You're going to get the diamond ring effect here. Woo!
I don't see it.
Whoa!
Look, take off your glasses. Take off your glasses. Oh my
Woo! Woo!
Oh my. Zoom in. Wow. Oh. It's not working.
Oh yeah.
It's pitch black in here.
It is really dark here in New Hampshire. You can see the prominences over on the right.
Wow.
Oh yeah. Wow. Big prominences. Yeah. Wow. Whoa, there's a huge prominence at the bottom. Oh my God, look at that. You guys see that?
Yes.
That is an enormous prominence. Huge prominence sticking out of the bottom of the sun. That is a really big one. That is like 15, 20 Earths across. Wow. Oh my God.
That's a bat.
It's a bird.
A bird or bat?
Wow, look at the size of that prominence. Woo! Oh my God. That is enormous.
And the cameras on your phone doesn't do justice at all.
Wow. You guys see the corona?
Yeah.
Woo! Oh my God.
How do you get a proper photo on this?
Wow. You guys believe that?
Yeah, the camera doesn't give it justice though. You can't get it like that.
The bats, there's some bats flying around.
Wow, look at that. Look.
Oh, diamond ring effect. Woo! All right.
Wow. Oh,
Woo!
Let's break that up. Wait, look at the ground. Uncle Sam, look at the ground.
Yeah, we're still getting shadow bands. Those are called shadow bands.
Yeah, look at the ground.
Yeah,
Where are the shadow bands?
these lines. Yeah, they're called shadow bands.
Oh, yeah.
Sorry, we lost the image there for you folks. I'll get it back in just a minute. Try to get out of full screen here.
oh my God. Oh.
I hope you all enjoyed that. I'll get the image back for you in a moment so you can see the partial eclipse again. But totality has ended.
I can't see anything. how bright it is already. How's that even?
I'm trying to beat the traffic. I'll see you in like 3 minutes.
Oh, sorry about that, folks. Can't seem to. Hey there, everybody.
What's the temperature outside?
It
says 61.
hope you enjoyed that.
Well, it's about 67 when we started.
Oh, my sister was here. Well, folks, couple moments of totality for you. Hope you enjoyed that. Hope you learned some stuff about eclipses. Looks like the folks in Indiana still have their partial eclipse going. You can see a little bit of it there. We might take a moment to take a look at the partial eclipse here in New Hampshire, and then we've got about a 4.5 drive back home and eclipse traffic. So yeah, woohoo indeed. So we're gonna get going, but thank you all for joining us. I hope you enjoyed that, and yeah, I think I might travel somewhere to see the next eclipse. So again, thanks everybody, and we will see you next time for the next big celestial event at Wyoming Stargazing. Have a lovely afternoon. See you later.
It's funny. You take off. It's still pretty cool to see.
Later.